Rule number 2. When you have that constant in front of the function, like we saw when we had 3x to the half, that constant it stays there. It doesn't affect it. So the same things happen here. Our exponent is n, so our power rule says that n comes out in front. And even though we have this a here, now a is just going to get multiplied by n. And we still subtract 1 off of our exponent. So really what the constant rule is telling us here is that it really doesn't affect it. You apply the same rule as rule 1, and a number in front just means that you're going to have to multiply that number in front by that. So here we've got 4x to the 7. If my 7 were to come in front, 7 times 4 is 28. Subtract 1 from the exponent. 28x to the 6. Okay, another 15-second head start. How did you do? And then in part C, we do have to take some time, and take your time on this. Take your time to change it to the proper form. Notice that only the x needs to come to the top. That 3 on the bottom stays as a fraction of 7 over thirds. 7 over thirds, that sounded wonderful. Nice. Now with the 7 over thirds, you're going to multiply it by a negative 2 over thirds. And you'll get negative 14 over thirds. Now when you subtract 1, continue our theme of bad English, you get negative 5 over thirds. So having that number in front doesn't affect anything. We don't have to show, like, I'm not expecting you to show, oh, the number came out in front, and then I subtracted 1, and then multiply them afterwards. It's so easy to go directly to the answer still that you don't need to do that. So far, I actually think this is all combined as one rule. Whether there's a constant in front or not, we're doing the same idea. So I'm not actually thinking of this as 2 separate rules. Same thing with this one. The derivative of a constant is 0. This can be seen as an extension of our last 2 rules as well. I would like you to think of 5, okay? First of all, if you graphed y equals 5, this is what it's saying here. What kind of graph is that? From a graphical perspective, that's a horizontal line. You pick any point along this horizontal line and you draw the tangent. The tangent is going to be exactly the same as the line itself. And the slope of that line, the slope of our line, is going to be 0. So from a graphical point of view, this is easy to see that any constant, doesn't have to just be y equals 5, is going to have a slope of 0. We can also prove this using our power rule. Let's say I have y equals 5, and I would like to write it as 5 times x to the something to make it still equal y equals 5. What would go up here? It would have to be a 0. Do you agree that 5 times x to the 0 is the same as 5? We've seen that in binomial expansions, right? That's how we find our constant term. We say all of our x's will cancel out, and we'll have an x to the 0. Well, let's say you apply your power rule to this. Your power rule to this says, it says for any rational number, so first of all, we bring the 0 out in front. What's 5 times 0? 0. And then you subtract 1 from the exponent. Well, now I have 0 times x to the minus 1. What is 0 times x to the minus 1 always going to be? It's going to equal 0. So we could also use our power rule to show this. Okay? Over time, though, excuse me, over time you're going to see a constant number, and you're just going to, it's going to happen so often, you're just going to go, oh, I know the derivative of that is 0. It's just going to disappear. All right. So now here's one. It's saying the derivative is 5x to the 4. Can you find out what the original equation would have to be? Okay? And this is alluding to something we're going to be doing later because of the working backwards. I made it. Good? Yeah. Whew. That was good. Yeah, I'll come talk to you. A little pale? Okay. So can you think of a function that if you did the derivative, you would get 5x to the 4? Be x to the 5. So if the number came out in front, I would have the 5, and I subtract 1 from the exponent, I'd have the 4. All right, and we have, I think, some practice questions listed after that.